During the time that I've been building these differentials, which is I think about 16 years now, I get asked quite often, do you make a cheaper one? Or that's far too expensive. Well, custom work doesn't come cheap, but I put together this video just to show you can build a really simple chain drive differential for not a lot of money and with no real amount of equipment, no need for a lathe, no need for a welder. You can buy most bits in. This one is based on Mazda MX5. It's one of the early 1.8 Mazda. That's the sort of Mark 1, Mark 2, what's that, NA, NB series of Mazda MX5s. This one's from the 1.8 version, which is slightly larger than the one that's fitted to this 1.6s. It has a larger crown wheel and a larger body and larger outputs. This technique can be used for either of the smaller ones or the bigger ones, or you could even put this conversion onto a Blackline Mazda MX5 ATB differential, which is a torque biasing LSD. They're available fairly cheaply. You can buy in the sprocket, you get them pre-machined. They'll bore them out to the diameter you require and put in the necessary number of holes. Right. There's an open MX5 differential. You can tell it's the open type. You rotate one of the output shafts backwards, the other one goes forwards. Right, I need to get these outputs out. They're just held in with a couple of clips internally. You just need a sharp tap to move them. Just like that. Now there'll be oil in the differential, which is liable to pour out everywhere. The rear case can contain all that oil if you tip it up that way. All we have to do is remove a ring of bolts now. A bit rusty. There's one 12mm bolt, headed bolt, doesn't want to come out, head's rounded off, tried various undersized sockets on it, still doesn't want to come off. Right, ground the head off of that. Now here's the difference between the smaller 1.6 Mazda differential and the 1.8 differential. You see the casings are considerably bigger, the crown wheels are larger. This one has 1, 2, 3, 4, 5, 6, 7, 8 bolts. This one has 10 bolts. The bearings on these are 40mm, that's on the big one. And the smaller ones, 35mm diameter bearings. Obviously we have different sized oil cans to make. That one's made from a 4-inch can and this one's made from a 4.5-inch can. Still be cut down. Trimmed down to size. So obviously need to make different sprockets for the two of them, different bearings. These are the 35mm bearings for this one. Well, I need to get housed bearings 40mm diameter for that one. The output shafts, this is the larger one for the 1.8s. It's a much stronger shaft, bigger diameter. Get my measuring device out. Yeah, 110 across that one, and these are 100. So larger flanges. The bearing spigots are 40mm on the big ones, 35 on the small ones. PCD on the 10 is I think 134mm, and on that one it's 114 for the 8. And that's 96, and that will be about 102 or something. Have a bigger caliper to measure that. $108. So it's 108 the face that the sprocket will bear on, and that one's 96. So that's the differences between the two MX5 differentials. Small and light, large, heavier, stronger. There's several ways of making an oil retaining can, or lubricant retaining can if you're using grease for these differentials. The sprocket is sitting almost on that edge there, so it's quite difficult to seal that up. What you can do is have the sprocket sitting on the outer rim of the can, so if that was fitted on there, a tight fit, the sprocket would sit on that outer face of the can. This leads us to another problem in that the M10 bolts, you wouldn't be able to get a nut in there. Sometimes I fitted a threaded backing ring that picks up all 8 of the mounting holes. So the bolts come in from the other side through the sprocket and then thread into the backing ring. The other thing that you can do is go down to an 8mm bolt from the back and sleeve the holes down with bushes to 8mm, and you can then get an M8 nut on the back. There's clearance. You can use thinner rings. This is a 10 gauge aluminium can. You can go thinner. You could make out a thin sheet about 1mm. You know, rivet yourself up a circular form. But I'll make a can up similar to this one. Doesn't need welded. All I've done is formed a dished aluminium plate for the top, knocked it in, and it could be held in with some sealant and a couple of rivets just to stop it falling out. See the inside, it's got a lip on the edge, pushed in. This one's a bit larger than the one we'd be using for this. So what I'll do, I'll just be marking it out here, I don't know if you can see it, just put a centre punch in there, and then marked out a couple of concentric circles, scribe them out. So I'll bend it at that inner line and I'll have it trimmed off at that outer line. Just a case of beating a lip onto it and then slipping it inside the can, so it can be sealed on and then riveted as well. And there'll be a whole board in the end. I think it's 35mm. Roughly cut out the shape to start with. You get a neater cut if you take the worst of the excess off, and then you can just follow the line round. close enough to a circle. So I'll just take the pliers and start forming an edge. If I measured it correctly and made the appropriate allowance for the thickness, it should slip inside the aluminium tube. As you do this, of course, it's going to turn into a cornflake, so you need to straighten it out somewhat when you start beating it into shape. It'd be handier if you had a shrinker to get the edge round. It's a little bit of massaging with a hammer will get it close enough. Big lump of metal. Let's see if I can. Start to get a bit more shape to it. So I'll just keep working at that and see what I come up with. Oh, after a couple of minutes of massaging, I've got a semblance of a lid. It should just about fit in there. Nearly flush in there. There are other ways of doing it. So you can start a can by folding up a piece of thin aluminium strip. You can joggle the joint on it, rivet it together. You can put countersunk rivets in from the back and pin them down on this side, and it will be nice and flush on the inside. And you can do a similar can for the end of it. The other alternative, you can sometimes find a large canister oil filter and use a body from that. Just cut off the base with all the filter itself and just use the can. This one's not quite big enough. This is about 2mm too small to fit on that, but a bit of searching in your local motor factors, you should be able to come up with a can that's a suitable diameter. And then it's again a case of just cutting a 35mm hole in the end, dropping it on. Right, I've measured the distance from that face to the face of the flange there, and allowing for the thickness of my end plate here, which is only 1mm. If I mark this at 72 or 73mm and cut the tube to that length, it should be fine to slip over there. So I'll just use my old calipers to scribe a line. I like to go round and put a guideline in so the blade has a chance of following the line. Yeah, I do have a large bandsaw that I could cut this with, but you can do it with a hacksaw if you're careful. Like I said, I'm just putting an initial line, a cut at the line, so you've got something to follow. That's the bit we want. And that can get pushed in there and sealed in and riveted. These are the housed bearings I'm going to be using that will go on the spigots here. I'm going to fit them, I'll show you what they're made of. I've got the bearing there has a curved outer edge to it, which rides in a curved housing, which can pivot like that. So that gives you adjustability of the angle, which is described as a self-aligning bearing, as it aligns, and then you can clamp it up solid. I'm going to fit them with the bearing outermost and the sleeve down here. The grub screws on the sleeve will grip onto the spigot. Spigot of these slightly tight on these, so what I'll do is ease the spigot journal. I'm just using a piece of inside out abrasive belting. I'll just work it round. Just take a couple of thousands off, just to get a good fit. It needs to be just a sliding fit, no more, because you want to be able to get it back off it again. Just a wee bit at the bottom. Anyway. Gently persuade it. That's it. Just needs a little bit more at the bottom, I think. So as I was saying, this is going in with this protrusion on first. But remember, when you're putting the bearings on, to first put one half of the plate on. So that needs to be gone first, and then the whole lot slides on. Second half goes on, clamps together. When this is seated fully, there's from the top face there down to the end of the spigot, it's about 12mm, which we'll use to our advantage because we can put an oil seal in there. Push that all the way out, that's fine. This is the output shaft. Normally the oil seal would run on that shoulder there. Unfortunately, this bearing doesn't come out far enough to reach that shoulder. We're going to have an oil seal about here. What we can do is we can slip on a V oil seal, which can expand over this section, and then it will grip on the shaft there, and then it will run on the face inside there. Let's see if you can see that. So there's a gap there. The oil seal will actually be inside there. We can put a packer on the back of this as well, just to make sure it stays down in there. It's not going to be a perfect oil seal, but as we're using grease, it's really just to stop muck getting inside. That's the can end plate drilled for the 40mm hole there, and cut to length. What I need to do now is I'll probably put 3 or 4 holes around there and put in some countersink rivets to hold to the end of the end cap into the can, and I'll seal it up with some polyurethane sealant when I finally fit it. I've also made up a sprocket. This was an old sprocket I had lying about that was drilled for a different fitting, but I've re-drilled it to 134mm, and that slips on. Well, it's kind of tight on the top edge, but it does slip on. There we go. And then I'll just fit 5 of these bolts in from this side, washer on the back, and a lock nut. That'll hold the sprocket on. 5 bolts will do. temporarily hold it on with these clecos just to keep it in place. Mark some witness marks there so I know which way it went on. Just drilling holes to put in the 1/4 UNF grease nipples. Found it. That's right, you should tighten in nicely. Next thing I need to do is plug up 3 holes here. There's a hole in the faceplate, 2 holes at the side of the spigot. I could put a little aluminium plug in them, or drill and tap them and put a grub screw in and seal it, or I could just put a big blob of polyurethane sealant in there, which is probably what I'll do. It's the easiest method. That one there, that hole there, is actually the access to knocking out the pin that holds in the cross pin. So I think I'll just plug these up with sealant. These holes at this end don't matter so much because there's going to be sealant put around there to seal the end of the can. The can's sitting on that lip there, and it'll also be sealed. The can will be sealed round this edge here. So for the can itself, you need to knock the end plate out again, put sealant on it, put it back in and put the 4 rivets in. So brake cleaner to clean this stuff up. Right, I've plugged up the 2 holes there and that hole with some of that polyurethane sealant. All I need to do now is screw in these 2 grease nipples. In fact, before I do that, I better put the sprocket on, because the sprocket slides over there. As I say, it's quite a tight fit for the first bit. It's a wee bit tight over the rivets. Just been painting the flanges for the outputs. Also pulled out one of the alternative type of CV joints to compare. This one is the flanged type. It takes the bolt-on CV joints, and this is the push-in type. It has the 1, 2, 3, 4, 5, 6 ball constant velocity joints, and that just slots in the same. Same splines, same lengths. So I've applied some of that polyurethane sealant to bond that on. Just go down and touch, no more, and then there's about another ½ millimetre of movement. We'll compress it very slightly. So I'll let those cure. The next thing is the bearings. Remembering to put on the first ring, then the bearing, slip it on, and find mysteriously Imperial. Get them roughly aligned. Put some temporary nuts and bolts in these to hold them. So, there we have it. Mounted between the two sets of bearings. So these are self-aligning plates, so you can just slacken off the bolts, the two halves, and square everything up once you set it in your chassis. Got plenty of clearance here between the bolt heads by having the spigot on the inside, the projection on the inside of the bearing, and it clamps on the spigot of the differential fine. So there you have a very simple way of making a chain drive differential without the need of any machining using lathes or anything like that, and no welding. Everything was done with hand tools and relatively cheap, I think the bearings and seals came in at about £40. Sprockets, these are normally, you normally get one for about £50–55 depending on size. You can get them pre-machined, so you don't have to machine them at all. You just give them the dimensions and they'll bore it and drill it. The oil can was very simple to make. It was a piece of 4.5-inch OD 10 gauge aluminium tube with just a piece of 1mm aluminium formed into a cap, then glued and riveted on. And the differential itself was an MX5 1.8. It was a type that had the flanged outputs with the 110mm PCD of 4 holes, but it's also interchangeable with the 1.8 push-in CV joints from the MX5. You'll probably be able to pick up an open differential from an MX5 for about 50 quid. So all in all, there's probably what, £125 all up, depending what you pay for your LSD, or not your LSD, your open differential. It didn't take too long to make either. To lubricate the differential, I would just use an ordinary lithium grease or something like molybdenum CV joint grease, and pump it full of grease. Just fill the whole thing. You can put one output shaft in and just pump grease in through the open end and work it in as far as you can. Shove in the other output shaft and then fill up any remaining space using the grease nipples. Just keep pumping grease in. Fill it up totally. So that was the larger of the two differentials from the MX5. That's the 1.8 version. It has a bigger crown wheel on it, bigger case, and larger diameter output shafts.